Hello, now Gbemi. Let's continue from number 11. The question in number 11 says you should simplify or find the value of n if n permutation 3 over n combination 2 is equal to 6. You write your steps out like this. And n permutation 3 over n combination 2 will give you n factorial over n permutation 3 is n factorial over n minus 3 factorial, like this. So n combination 2 also is n factorial over n minus 2 factorial times 2 factorial, like this. Since we know that the formula for n permutation r is n factorial over n minus r factorial times r factorial, you know how that should be written. So here, n permutation 3 will be this, then divided by n combination 2 will give you n factorial over n minus 3 factorial times, you know how we do fractions by switching the next fractions, denominator and numerator, n minus 2 factorial times 2 factorial over this. So if you simplify very well, this will simplify, n factorial we cut n factorial here. So you have n minus 3 factorial here, n minus 2 factorial here, then 2 factorial. So your answer will be left with n minus 2 factorial times 2 factorial over n minus 3 factorial. Now, know that n minus 2 factorial is the same thing as n minus 2 times n minus 3 factorial. So that's what I have written here, that n minus 2 factorial here will give me n minus 2 times n minus 3 factorial. So times 2 factorial over n minus 3 factorial. So n minus 3 factorial cannot cut n minus 3 factorial. You can see that. So you'll be left with n minus 2 times 2 factorial. N minus 2 times 2 factorial is this. And you simplify to get your n is equal to 5. The next question says 4 couples are seated on a bench. In how many ways can a particular couple sit together or not sit together? 4 couples means 4 times 2 people. So that means you have 4 husbands and 4 wives, 8 people. If 2 couples sit together, it means they will be seated as one group. So assume that the 2 couples are sitting together. The remaining 6 other people are 1, 2, 3, 4, 5, and 6. You know, you put those ones on dashes like this. That the remaining other 6 people can sit anywhere on these 6 positions. But the 2 couples that must sit together will be either here before the first person, or here between the first and second person, or here between the second and third person, or here between the third and fourth, or here between the fourth and fifth, or here between the fifth and sixth, or here after the 6th person. So that means there are 7 different ways of positioning those 2 couples that must sit together. Now, when those 2 couples are sat together too, let's say they are M and W, there are also 2 different ways of sitting them. You can see the man first and the woman next, or sit the woman first and the man next. You know what this means? So that means there is another 2 different ways of sitting the 2 couples. Then multiply this by the 6 factorial ways of arranging the 6 other people. You get a total of 10,080. Now, the next question in B says, if they must not sit together, how many arrangements will you have where the 2 couples must not sit together? Altogether, the total number of unconditional arrangements of 8 people is 8 factorial, which will give you 40,320. Let the number of ways where the 2 women sit together be P, and let the number of arrangements where the 2 women don't sit together be Q. Now, P plus Q will give you 40,320. So 10,080 plus Q will give you this, and Q will be this minus this. That will give you the number of ways where they must not sit together. You can subtract that yourself. Now, number 13 says, how can 6 pupils be lined up if 3 of them must follow one another? Let's say the number of those that don't mind where they sit or line up is 6 minus 3. So this 3 is the number of the 3 children that want to sit together or line up together. 3 talkatives. So the total number of ways of doing this arrangement will be that the three others that don't mind where they line up will be lining up here, here, or here. Any one of them can occupy these three positions. But those three that want to line up together can be before the first person, or between the first and second person, or between the second and third person, or they will line up after the last person. So that means there are 4 different positions for the 3 talkatives to, be lined up together. Now, 4 different positions. Now, when you are lining up those 3 people also together, let's say they are A, B, C. They can be lined up as ABC or ACB or BCA or BAC and so on. So there's another 3 factorial ways of arranging that. 3 factorial ways times 4 ways of positioning the 3 of them times 3 factorial ways of arranging these 3 other people that don't mind where they stand. You get a total of 144. Number 14 says, a committee of 5 men and 4 women is to be formed from 9 men and 8 women. Find the number of ways in which the committee can be formed, unconditionally. This means unconditionally. The number of ways the committee can be formed if it must have 2 particular men. Now, if the committee if the committee is to be formed unconditionally, no condition, you just choose 5 men from 9 here, and you choose 4 women from 8 women here. Number of ways of doing that is 9 combination 5. Number of ways of choosing 4 women from 8 women is also 8 combination 4. So 9 combination 5 times 8 combination 4 will give you 8,820 ways. Now, B says, if 2 particular men that you have identified must be on the committee, how many arrangements do you have? Now, if 2 particular men must be on the committee, that means you are not doing any selection for those ones anymore. You just know that 2 men must be on the committee. So you now have 3 more men. That means you have 3 more men left to choose from the remaining 7 men. So you do 7 combination 3, number of ways of choosing 3 men from 7 men, and 8 combination 4, number of ways of choosing 4 women from 8 women, and you get this. Now, number 15 says that you should simplify or show that n plus 3 factorial over n factorial is this. Now, let's write it from the left. N plus 3 factorial is supposed to give you n plus 3 times n plus 2 times n plus 1 times n factorial. You know how we decrease our numbers by 1 when doing factorials. So divide this by n factorial. N factorial will divide n factorial, and you have this left. I will say number 16 in a bit. Then number 17 says, selecting, in how many ways can 3 books be selected from 12 books? That's straightforward, pretty simple. Number of ways of choosing R items out of n items is 12, is n combination R. So choosing 3 books from 12 is 12 combination 3. That's 12 factorial over 12 minus 3 factorial times 3 factorial. That will give you 9 factorial here, and you simplify, divide. 3 factorial is 6. So what I've done here is 6 in 12, 2, then 220 ways. There will be 220 ways of doing that. Then number 18 says, in how many ways can you arrange the letters of the word cross? If there's no restriction, the letters of the word cross has 2 s. So our number of, letters is 5, but there are 2 repetitions, so 2s. N factorial over A factorial times B factorial times C factorial. These are my repetitions. That's how we do, arrangements where there are repetitions. So this will give you 5 factorial over 2 factorial, and you get 60. Now, if the arrangement is to be done in such a way that it always starts with an S. Now, what this means is that you have 1, 2, 3, 4, 5 letters to arrange. But if it must start with an S, it means there are 2 ways of, doing that, starting with an S, because there are 2 S's. Now, after writing the first S, you will now have 4 different positions left and 4 letters left. So there will be 4 ways of writing the next letter, 3 ways of writing the next one. After doing this, there will be 2 letters left, 2 ways of writing one here, and 1 way of writing one here. But since the 2 S are indistinguishable, we have to divide this answer by 2, because this is pretty somehow confusing. So in order to remove the confusion, we divide the total answer we get by 2, so that the number of different arrangements will now be the answer divided by 2, 24. Next question is number 9. 5 boys and 5 girls are seated at a round table so that boys and girls occupy alternate seats. In how many ways can this seating arrangement be performed? When arranging objects around a circle, we always say the number of ways of doing it is to stand the first person anywhere and now arrange the remaining objects or persons as if they were arranged on a row to the right or on one side of that first person. So this first person can be here, it can be anywhere, But now, stand the first person somewhere. The first person now here can be a boy or girl. So there are 2 ways of doing that. 2 ways of seating the first person in the round table. After seating the first person here, the first person is a boy or girl. There will now be 9 other persons to sit. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 other persons to sit means that we have either we start with a girl. There will be 5 ways to put the first girl down. If this was a boy, there will be 4 ways to put the next girl down. Here, there will be 3 ways here to put the next girl down. There will be 2 ways to put the next girl down, and the last girl 1 way. It is the same thing if we had started with a boy. If we had started with a boy here, after seating the first boy, there will now be 4 boys left. Sorry, if you had started with a girl, after seating the first girl, there will now be 4 girls left and 5 boys left. So 5 boys, there will be 5 ways of seating the first boy, 4 ways of seating the second boy, 3 ways of seating the next boy, 2 ways of doing this, and 1 way of doing this. Then the 4 girls too will occupy these alternate positions here. This place, this place, this place, this place, and that's all. So 4 ways, 3 ways of seating the next girl, and so on and so forth. So you get 5,760 ways. But since the arrangement looks the same, whether we start with a boy or girl, the total different arrangements will be 5,760 divided by 2. Let's go to number 20. Number 20 says, in how many ways can at least 3 out of 5 people be seated in a row? This is a question on combination. Seating 3 people in a row out of 5 involves selecting 3 items out of 5. So at least 3 means 3, seating 3 or 4 or 5. Number of ways of choosing 3 objects out of 5 is 3, 5 combination 3, or choosing 4, 5 combination 4, or choosing 5, 5 combination 5. So that gives you 16 ways. I'll see you in the next video.